time, position, velocity. Well, till now, graph was given to us, and from there we are trying to write a story. We're trying to read the parameters like distance, time, and we're trying to calculate speed or velocity, right? Now, we have kind of twist on this. We will now create a graph given position and velocity, right? So that would be kind of interesting, right? Let's look into this one. It's a very simple, basic example, but gives you a good foundation to start with. Create a time position graph for an object with a starting position of 10 meters and velocity of 15 meters per second, right? Important things here to consider are units. First thing we should look into is units, right? Now, two things are concerned. First is time position. That means independent variable is time for us, and position, that means distance, is our dependent variable, right? So let's write t along the horizontal axis and d along the vertical axis. Second, we're talking about units, right? Starting position is 10 meters. 10 meters away is the distance, right? And it is meters is the unit. So we'll write meters here. And the velocity is meters per second, 15 meters per second, right? So per second means time unit is seconds for us, right? So that's how we get our units. Now we should look into the scale of our graph. Now it means starting position is 10 meters. That means each unit should be at least 10. It could be 5 also, right? Then in that case, that will be 10. Is that okay? Right? Now, the second part is velocity is 15 meters per second. That means every second the object is going to move 15 meters, right? So that is how we have to add 15 to 10, right? So we get 25. Therefore, it's a good idea to take 5 as our basic unit, right? So for distance, we'll take 5, and so we'll use this as 10. The two numbers, right? So 5, 10, 15, we'll use 20, 25, 30, then 40, correct? Likewise. Now, it is meters per second. So we are going up by 14 meters every second. So we can use this as 1, 2, I'm writing 2, 3, 4, 5, 6, 7, 8. So that becomes the unit for time. So scale is 1 second along the horizontal axis gives us time in seconds, and 1 unit along the vertical axis gives us distance 5 meters, right? So that is the scale which we have taken, right? Now, once the scale has been fixed, now it's easy to draw a good graph, right? Starting position is 10 meters. That is d-intercept, right? 10 meters. So we'll make this is our initial position, starting position, 10 meters. Velocity is 15 meters per second. Since the velocity is positive, right? So velocity is positive. I'm writing positive purposely, meters per second. It means that the distance is going to increase, right? So distance increases. Do you understand? And the rate at which it increases is 15 meters every second, 15 meters per second, right? So in the first second, it has to increase by 15 meters. So as you go time unit by 1 second, your distance should increase by 15 meters, right? So that means 10 and 5, 15. So that becomes the next position. So next second, 15 more, right? So next second, it goes 15 more. So 5 and 10, 15. So that becomes our next position, right? Joining these lines will give us the time distance graph, right? So let's join them. So here are the 3 points align, and we can join them and draw an arrow at the end, right? So that indicates a time position graph for the given situation, correct? So that is how we are going to draw it. I hope you understand and appreciate it. Thank you.